Welcome to the Explainer. Look, let's be real. Every single AI project lives or dies by its data. The pressure isn't just to get more data, it's about getting the right data. But what does right even mean? Today, we're going to decode the one thing that separates successful AI from those frustrating failed experiments, a truly smart data strategy.
I mean, this quote really says it all, doesn't it? Every algorithm, every prediction, every little insight an AI spits out, it's all born from the data you feed it. Think of it this way. Without data, there's no intelligence. All you've got is an empty, expensive machine.
And here it is, the million-dollar question. The one that keeps project managers and data scientists up at night. You know you need data, but the sheer ambiguity of how much can stop a fantastic project dead in its tracks. Are we talking 1,000 records? 1,000,000? 1,000,000,000? What's the magic number?
Well, the simple and, often infuriating answer is it depends. But wait, that's not a dead end. In fact, it's the beginning of a much, much smarter conversation. The amount of data you need isn't some number you pull out of a hat. It's the result of asking the right strategic questions first. Think about it. Are you trying to spot a simple pattern, or are you modeling something incredibly complex? Like, say, the global supply chain? Are you building a totally new model from the ground up, or can you just tweak an existing one? And let's be honest, how accurate does this thing really need to be? These factors completely change the data equation. So to get past that "it depends" answer, you need a system. You need a structured approach. There are proven methodologies out there that give you a framework, basically a checklist of critical questions that force you to think strategically about your data before you ever collect a single byte. Just look at this list. These are the conversations you have to be having. Where is this data even coming from? Is it ours? Can we legally access it? Is it a complete mess? And here's a big one. Maybe, just maybe, has someone else already done the heavy lifting for us with the pre-trained model? Answering these questions, that's your first real step to a successful project.
Okay, next up, let's get on the same page with our vocabulary. Your data strategy is probably going to involve two key ingredients, what we call ground truth data and synthetic data. And understanding the difference between them is absolutely crucial.
On one hand, you have ground truth. This is the real deal, data from the actual world. We're talking real customer purchases, real sensor readings from a machine, real medical scans. It's authentic. Then, on the other hand, you have synthetic data. This is data we literally create from scratch. It's artificially generated to look and behave just like real-world data. And this is a game changer when real data is super scarce, expensive, or locked down for privacy reasons.
And believe me, this isn't some far-off theoretical idea. Synthetic data is a powerhouse that's being used right now. It's how you can train a self-driving car on 1,000,000 terrifying edge cases without a single real-world fender bender. It's how you build medical AI without ever violating patient privacy, or how you spot financial fraud by modeling transactions instead of using the real sensitive thing.
So if the thought of collecting all that data from scratch has you sweating, I've got some very, very good news. You don't always have to start from zero. The modern AI landscape is absolutely filled with powerful shortcuts that can save you a ridiculous amount of time, money, and headaches.
First up, the pre-trained model. This is like hiring an expert who already has 90% of the skills you need. I mean, why build from scratch when a massive team has already spent millions of dollars and tons of computing power training a model on a gigantic data set? A lot of the time, you can just take that finished model and use it right out of the box.
Okay, but what if that off-the-shelf model isn't a perfect fit? What if it's close, but not quite right for your specific problem? Well, that's where this brilliant technique called transfer learning comes in. This is where you take the foundational knowledge, the brain of a big, pre-trained model, and then just fine-tune it with your own smaller, specific dataset. So here's how it works, basically. You pick a powerful base model. You find the part of its digital brain that has already learned general stuff, like how to recognize shapes or textures or sentence structures. Then you basically bolt on a new, much smaller neural network, and you only have to train that new little part on your specific problem. You get all the power of the huge model without the massive cost of training it yourself. It's the best of both worlds.
And this all leads us to the true titans of the modern AI world. foundation models. You've heard of them, even if you don't use the name. We're talking about large language models, massive image generation models, these things. They're trained on absolutely staggering amounts of data, and they aren't built for just one task. They're designed to be a starting point for almost any task. They are fundamentally changing how AI gets built.
And hey, you don't have to take my word for it. This quote from IBM Research just nails it. We're moving away from these narrow, one-trick pony AI systems to these broad, generalist models that can learn and adapt across totally different problems. This isn't just an upgrade, it's a massive shift in the whole AI paradigm.
Okay, that was a lot of theory, so let's ground all this in reality. How does this stuff actually play out in the wild? Let's take a look at a couple of real-world case studies. Our first stop is NASA, with their project on predictive maintenance for turbofan engines. The goal sounds simple, but it's incredibly high stakes. Predict when an engine is going to fail before it actually happens.
Now, to solve this, NASA tracked data from 21 different sensors on every single engine. Just try to picture that for a second. 21 constant streams of data for pressure, temperature, speed, you name it. But it was all super noisy and every engine behaved a little differently. This is your classic ground truth challenge, trying to find that one tiny critical signal of failure buried in an absolute avalanche of noisy data.
All right, next, let's jump to a totally different kind of problem. Coca-Cola needing to moderate brand-related content online. So they needed a way to automatically identify images that featured their products, but also flag any content that was inappropriate. You know, not safe for work.
And their solution here is just so smart. It's a brilliant hybrid strategy. For the part that was unique to them, identifying their own bottles and logos, they built a custom model using thousands of their own internal images. But for spotting general NSWSF content like violence or hate speech, they didn't reinvent the wheel. They just plugged in an existing pre-trained model that was already an expert at that. It's the perfect mix. Build what's unique to you, buy what's common.
So, after you've asked all the right questions, you've explored your options, you get to this critical business checkpoint. This is the go/no-go decision. This is the moment of truth where you have to be brutally honest and assess if you actually have what you need to move forward. Hitting one of these roadblocks doesn't mean you failed, it means you're being smart. If you realize you need data that's basically impossible to get, or it's so messy it would take a year to clean, or you run into a legal wall, you stop. You don't just charge ahead, you iterate. You might even have to redefine the whole project. That isn't failure, that's smart management.
And that brings us full circle. We started this whole explainer by asking, how much data do you need? But I hope you see by now that's actually the wrong question. The right question, the much more powerful question, is this. How smart is your data strategy? Are you asking the tough questions up front? Are you leveraging shortcuts like pre-trained models? And are you being honest about those go/no-go moments? That is what really determines success in AI.